Hi there, this video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the first video of 6. It will focus on questions 1 to 5, which account for 22 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 1. Nathan and Lucy make and sell wooden items for gardens. Part A. Nathan makes and sells benches, tables and tool sheds. Last year, the profit he made from selling these items was in the following ratio. So benches to tables to tool sheds, 2 to 3 to 7. What fraction of his profit did Nathan make from selling benches and tables? So we're going to need to write each part of this ratio that relates to benches and tables as a fraction of the total number of parts of the ratio. So the total number of parts, 2 plus 3 plus 7, 2 plus 3 plus 7 is 12. So we're interested in benches and tables. So benches are 2 out of those 12, so that's 2 over 12, and tables are 3 out of 12, so that's 3 over 12. We want the fraction of profit he makes selling benches and tables, so doing 2 over 12, add 3 over 12. If you're not comfortable with fractions, then enter it into your calculator. So 2 over 12, remember to arrow off before you press add. 3 over 12, that gives an answer as 5 over 12. If you are okay with fractions, you will have known that the denominators are the same, so we simply add the numerators. So 5/12 is our fraction of profit for selling benches and tables. Part 2. His total profit was £18,072. How much profit did Nathan make from the sale of tool sheds? Okay, so the sale of tool sheds is 7 12s. So 7 of those 12's total parts. So if we multiply this by the total profit, that will tell us how much he made from tool sheds. So 7 over 12, arrow off your fraction again, multiplied by 18,072 is equal to £10,542. So that's how much profit he made from the sale of tool sheds. Part B. Lucy makes and sells planters. Each planter costs Lucy £32 to make. Each one that she sells make a profit of £80. What is Lucy's profit from the sale of one planter as a percentage of the cost to make the planter? So the profit of the sale of one planter is 80. The cost to make the planter was 32. And we want it as a percentage, so we're going to multiply this by 100. So 80 divided by 32. Remembering to arrow off your fraction. I'm just trying to make it so you can see my calculator. It's not very bright. Arrow off the fraction and then multiply by 100 to turn that fraction into a percentage. So that's 250%. It's okay that it's 250%. We can have percentages that are bigger than 100. Question 2. The table gives a summary of the masses, m grams of 30 buzzards. So this is our table. So we have the masses and we have these classes, these ranges of values and our frequencies. Part A. Moeen uses the midpoint of each group to calculate an estimate of the mean mass of the buzzards. He does this correctly. Calculate Moeen's answer. So we're using the midpoint, and that's the midpoint of these two values here. So if you can't spot the midpoint, if you add the starting point 600 plus the end point 700 together and then divide by 2, that tells you that the midpoint is 650. And you can do that for each of those if you need to, if you can't spot what the midpoint is. Okay, so now to estimate the mean, we're going to do the midpoint multiplied by the frequency as our first step. So we're going to do 650 multiplied by 8, 750 multiplied by 7, 850 multiplied by 4, 950 multiplied by 11. So we're going to do those sums to start off with on our calculator because it's a calculator paper. Being careful what we enter into our calculator. We've seen in my previous videos that it's easy to make mistakes. So it's worthwhile being super careful. Okay, so to estimate the mean, we're going to total these together. So and then we're going to divide this total by the total number of buzzards. So 24,300 divided by 30. Remember, leaving things in our calculator makes life a little bit easier so we don't have to enter digits in and potentially make some errors. So I get an estimate of the mean mass of the buzzards as 810, and we're working in grams, so I'm going to pop grams there next to my answer. Part B. Dita decides to estimate the mean mass of these buzzards. She uses the values 600, 700, 800 and 900 rather than the midpoints. Explain why her method is unlikely to give a good estimate of the mean mass. So what Dita's done here is use the lowest possible value that it could be within each of these ranges, within each of these classes. So actually her answer is going to be an underestimate. She's using the lowest value, so the mean's going to be too small. So I'm going to say that she's using the lowest values, so the mean will be too small. Question 3. Debbie collects data about a group of 20 people. Her data is the total number of years for which they have owned a pet and the number of visits they have each made to their doctor in the last year. The scatter graph shows her results and her attempt to draw a line of best fit for the data. So this is her scatter graph and that straight line is her line of best fit attempt. Part A, make a criticism of Debbie's line of best fit. So a line of best fit, the aim of it is to give us an average that follows the trend of the data that we could potentially predict from if we need to. Now, the line follows the trend of the data in terms of it's following the same direction. It looks like it's got a negative correlation. However, there are no points above the line. And when we're doing a line of best fit, if we're wanting an average to estimate from, we need to be roughly in the middle of all the points. So we'd expect points to be on either side of that line. So what I'm going to say here, my criticism is there should be points above and below the line of best fit. Okay, part B. Debbie says, because there's a negative correlation, owning a pet for longer causes people to need to visit the doctor less often. Is Debbie correct? Yes or no? Explain how you decide. This is important. Don't just tick a box yes or no yet. We've got to explain how we decide, guys. All right? So, yeah, there's a negative correlation according to this line of best fit and the direction that the data's going in. However, correlation doesn't imply causation. There is absolutely no relationship between whether you own a pet and how many times you visit the doctors. There's no relationship between that whatsoever. So we can say, we can simply write correlation does not imply causation, or there is no relationship between them, it's just a coincidence. So I'm going to put that. There is no relationship between them, it is just a coincidence. And then I'm going to say Debbie is not correct because there isn't a relationship. How many pets you own have no bearing on how many times you might visit the doctor. Question 4. Janet invests £5,000 in a savings account for 9 years. She makes no further payments into or out of the account at this time. So that £5,000 is the only money that goes in and none of it comes out. For the first 5 years, her investment earns 2% compound interest per year. After this, the interest rate decreases to 1.3% compound interest per year. How much is Janet's investment worth at the end of the 9 years? So we've got 2 stages to this, guys. We've got the first 5 years and then the rest of the years. So we start by investing £5,000. And for the first 5 years, so I'm going to put that here. So the first 5 years, it's 2% compound interest. So we want 100% of the amount plus 2% interest, which is 102%. I'm going to convert that to be a decimal by dividing by 100. So 102 divided by 100. On a calculator, if you're not sure, guys, is 1.02. So 1.02 is my decimal multiplier that I'm going to use, but that's just for the first 5 years. So I'm going to raise that to the power of 5. Okay, this whole investment is for 9 years. We've dealt with the first 5 years, so we've got to consider the next 4 years. So the next 4 years have a compound interest rate of 1.3%. So it would be 100% of the amount plus 1.3%, which is 101.3%. I again want this to be a decimal multiplier. So 101.3 divided by 100 is 1.013. So that is my decimal multiplier for the next 4 years. So I'm going to raise that to the power of 4. I'm just going to pop this all into my calculator now as carefully as I can. So 5,000 multiplied by 1.02 to the power of 5. Remembering to arrow off from the power before I then start typing the rest of the sum. So then we've got 1.013 to the power of 4. And then I'm going to press equals. So this is 5,813.111385. We're working with money, guys, so we want to work to 2 decimal places. So that would be £5,813.11. Let's check what the question's asking us for. How much is Janet's investment worth at the end of the 9 years? Well, this is how much the investment is worth. That's what will be in the account at the end of the 9 years. (5A) Circle the correct conversion of 7 meters cubed to centimeters cubed. Okay, so if we were going from meters to centimeters, we would multiply by 100. Here we're going from meters cubed to centimeters cubed, so we need to multiply by 100 cubed. That's the important thing here. So 7 meters cubed equals 7 times 100 cubed. So stick that in your calculator. 7 times 100 cubed, which is 7 million. Guys, so make sure you circle the correct number. When they're multiple choice, don't just guess. Do some working out. 5B. The diagram shows a shape made from a trapezium and a circle. So we have a trapezium and then we have the circle. The parallel sides of the trapezium are tangents to the circle. So these 2 sides that are parallel are also tangents to the circle. So this tells us that they touch the circle at a point, but they don't cut through the circle. The diameter of the circle is 30 centimetres. The ratio of the white area to the shaded area is as follows. So the white area to the shaded area is 1 to k. Find the value of k, show all your working, and give your answer correct to one significant figure. Okay, so the first thing I'm going to recognise here is that we're working with area. Okay, so I'm going to start by finding the area of the trapezium and the area of the circle. So for the trapezium, to find the area, you add the two parallel sides together, so 62 and 79. So 62 plus 79. Then we multiply that value by the height, the distance between those two sides. So 141 multiplied by 30. And then we half that value to get our area. So the area of the trapezium is 2,115 centimetres squared. I'm now going to find the area of the circle. So we're doing pi times radius squared. Well, the diameter we're told in the question is 30, so the radius is half of that, which is 15. Remember, you can do 30 divided by 2 on your calculator. So the circle has an area of pi times the radius squared, which is 15 squared. So pi times 15 squared is 225 pi centimetres squared. I'm going to leave it in terms of pi so I don't have lots of decimals to enter into my calculator. So we're working with area. I found the area of the trapezium and I found the area of the circle. The next thing we need to deal with is that our ratio works in terms of the white area, which is the circle, and the shaded area. So we need to find out what the shaded area is. To do that, we're going to take the area of the circle away from the area of the trapezium. So here we're working with the shaded area. So the area of the trapezium, take away the area of the circle. So 2115 subtract my answer that was left in my calculator. Okay, so that is the area of the shaded region. So now we're going to go back to this ratio. So we've got the white area and the shaded area. So the white area is 1. The shaded area is K. Now we've said our white area is the area of our circle. So I'm going to pop that in there. So that's 225 pi. Our shaded area is this here. So that's 1,408.141653. We need to find what K is. So we need to scale this ratio down to get to 1. So what we would do to make this part of the ratio 1 is divide by 225 pi. So I'm going to do the same on the other side. So my answer's still in my calculator, so I'm just going to divide by 225 pi. So that tells me it's 1.99211,293. Now it asks us to give our answer correct to one significant figure. So that's 1 to the ratio of one significant figure here, guys. So the 1 in the units or the ones column is our first significant figure. The 9 next to it is 5 or above, so that's going to move up to 2. The question asks us to find the value of K. This side of the ratio is K, so K is equal to 2 to one significant figure.